Dear students, today we will understand the basic facts on dynamics of charge particle or the behavior of a charge particle, specifically an electron in an uniform electric field. Once you understood all the dynamics, especially its what is the force, acceleration, velocity, and kinetic energy, momentum of a charge particle and its behavior in a uniform electric field, it is very useful to understand the behavior of charge particle in magnetic field and electromagnetic field. Understand its basics correctly. Dynamics of electron in uniform electric field. Today we'll find what is the electric force experienced by electron in uniform electric field, acceleration of electron and velocity at any given instant of time, and kinetic energy of electron and trajectory of electron. These things we'll understand, so that once we understand the electron, it is the same way we can understand for any charge of negative or positive. The electron is only an example of a charge particle of negative type. If you use the proton, it is going to be positive charge. For after all these things, here go on attending the same thing to the proton. You practice for that. First, we will find all these physical parameters for these two situations. Electron placed at rest. First, we are going to keep the given electron at rest, that is with zero initial velocity, and we will find all these things. And similarly, in second situation, we will keep electron we are going to project or inject or an electron is traveling inside a uniform electric field with a certain initial velocity, and once it is enters, we are going to understand in this session only if that it travels parallel to electric field. Parallel means the two cases again will split. It is projected or traveled opposite to the direction of electric field, and another thing is opposite or in the direction of electric field. There are two cases we are going to understand when the electron moving in a electric field with a certain initial velocity. I'll take an example of this. Yes, before going to understand the electron placed at rest with a zero initial velocity, we are going to once again we will put all these parameters, that is identify the direction of electric force, acceleration, instantaneous velocity, the direction of an electron placed at rest in a given uniform electric field. Here these are the direction of uniform electric field. The lines are parallel. See, in any problem we come across uniform electric field, these four, only these four uniform electric field are left to right, right to left, vertically downward, vertically upward. In here only there we are going to understand the dynamics. That's why student has to, all of you has to practice perfectly one by one. First understand the electron and apply the same concept to all the particles. Only direction and in some of the case acceleration, retardation you have to take care. That's it. First I am going to keep an electron. If I am going to keep an electron and it's initially it kept at rest, is a V naught. Initial velocity I will represent V naught, it is going to be 0. I represent E. E is an electron here. And I'll keep the electron. V naught is going to be 0. E V naught 0. E V naught 0. Then there is no question of initial velocity direction because initially at rest. Now, whatever the magnitude and direction of velocity of initial velocity of a charged particle, it always experiences the force. What is the magnitude and all those things we'll understand later. The direction, and we know that a electron is a negatively charged particle, hence it is experience the Coulombic force or electrostatic force opposite to electric field. This is the direction of electric field. Arrow mark represents the direction of electric field. This is right to left, sorry, left to right, right to left. This is vertically downward and this is vertically upward. This is the Coulombic force direction. I am writing now the first one, Coulombic force. This is the Coulombic force direction, F, opposite to electric field direction. Here this is electric field force. Downward, this is upward, is a Coulombic force. Upward, this is downward. Acceleration. Acceleration is also in the direction of force. A, C. And velocity. This velocity is going to be velocity after time t. And we know that if the force is experienced by a mass, the electron is having the small mass, hence it must accelerate. Once it is accelerate with respect to time, its velocity go on changes. Hence at any given instant of time, velocity I represent it by Vt, it is going to be given by Vt, and Vt direction is the direction of change of momentum, rate of change of momentum in the direction of force. This is a Vt. Means it moves in this direction, force direction, automatically Vt is going to be this direction. This is going to be velocity. This is a velocity. This is also velocity direction. These are the directions. Now we can understand the what is the expression and what are the relations we are going to get for all these things. Here, the first, electron placed at rest. Understand the situation very clearly, and the same thing you have to apply for any type of charges. Electron placed at rest. Here, electron negatively charged placed at rest means with zero initial velocity. Here I am going to keep an electron and it has a mass. The mass of electron is going to be, I am going to represent it to be electron mass. Electron mass, I represent it by small m. Then placed at rest, then it is going to be V naught is going to be 0. This is the situation. We have to find the electric force. We know that whatever it is magnitude and direction, electric force F is equal to any charge experience the Coulombic force EQ, where EQ is, Q is in this case is the electron charge, is electron minus 1.6 in 10 raised to minus 19. This is E is equal to, Q is equal to minus E, therefore F is equal to minus E and Q is equal to E. This is minus E is because of this negative charge. Both are vectors. Magnitude wise, F is equal to, yes, you can write the vector sign or not. The F is equal to magnitude, the F is minus E. Minus sign represents that F and E are opposite to each other. Means the force is acting opposite to electric intensity. This is the Newton. Coulombic force is going to be Newton. Then acceleration. We know that electron has a certain mass, and here once it is going to experience the force, then automatically it has to accelerate. and we know all these dynamics in previous lower classes. And acceleration of this one is going to be given by F is equal to mass of the charged particle into its acceleration, implies the A is equal to F by m. And acceleration of this one is equal to F. What is the F? This is EE minus EE by m. This is the acceleration. What is this minus sign? The acceleration is also opposite to electric intensity direction. Therefore, here acceleration is also here. Force direction, rate of change of momentum is takes place here. Hence, A is also opposite to electric intensity. A is EE by m. Remember this. This is very important thing. There is no need to by heart or anything. It is only you have to understand how this equation we are arriving. This is all the basic things what you understood and learned in 11th standard. Then velocity at any instant Vt. This is what the thing. Initial velocity is 0, but when we kept the mass here, electron act as a mass now. It is accelerates, means it is moving with a constant increasing velocity. And question is, acceleration is a constant acceleration. Why? Acceleration is a constant because the force acting on this electron mass is also a constant force, because everywhere it is a uniform. If it is uniform means if you keep this electron anywhere in between this area, it experiences a constant or equal force. Hence the force is constant, automatically the acceleration of the accelerating particle must be constant. Then it is go on increasing its velocity constantly. That is a constant acceleration in the same direction. Along the direction of force, it is go on increase the velocity. If initial velocity is going to be 0, then after time t or at time t, that is called instantaneous time or velocity at any given instant of time. I am representing it by Vt. That is the thing. What is Vt? At any given instant of time or any time after t seconds. That is a Vt. Then Vt, initially which is 0, it is gone increasing its velocity. Then it again the velocity is greater than 0. What is its velocity after time t? That is going to be calculated by equation what we learnt in PUC 1 or 11th standard. Velocity after time t, Vt, is equal to initial velocity in plus acceleration into t. In this case, V naught is 0. This implies Vt is equal to 0 plus At. This implies Vt at any given instant of time, velocity of a accelerating electron is A. A is EEm into minus EEm into t. T is the any given instant of time. Here also E is always remains constant. Capital E is the electric intensity remains constant, and mass of a charge electron remains constant. T, with the time t, Vt is gone increases. Velocity is increases with t because it is accelerating. Every second its velocity is gone adding. Therefore, Vt is equal to EEt upon m, and this minus represents that Vt is going to be opposite. Velocity is a vector quantity, is opposite to electric intensity. Here also. This is another equation. Now kinetic energy. If it is accelerating, the very important thing is what is the kinetic energy basically. Kinetic energy is going to be equal to 1 by 2 m v square. Then initial kinetic energy is going to be 0 when we keep the initial velocity is 0. Hence initial kinetic energy is going to be 0. But with respect to time, the electron is gone accelerating, hence it gain the velocity at any given instant of time t. Then it is slowly, it is going to be kinetic energy is gone increases. With the time it is gone increases. Hence at any given instant of time the increasing kinetic energy, we call it as specially, be careful, we are using the word the increasing kinetic energy of electron. Whenever we use this word, you must be very clear that in an electric field, electron kept are kept basically rest. When you keep, it is increasing its kinetic energy because of acceleration. This acceleration is due to the force acting on it. And we are going to derive this equation 1 by 2 m square. Very simple, we already derived. M is the mass of a electron, m. V is nothing but velocity at any instant of time t, because it is increasing at any given instant, because not remains constant. Vt, and Vt is here E t by m square. Here kinetic energy is always positive because it's going to be scalar quantity. Then we will understand what is this kinetic energy, the work done and all those things future, but kinetic energy is always positive. This is equal to 1 by 2 m E square E square t square by m square. Then finally this equation, kinetic energy equation, is, remember this is very important, this is E square t square by 2m. Here E, a capital E, electric intensity, electric charge of electron, and the time at any given instant of time t. As it increases, kinetic energy increases. And at any given instant of time, if the two different charges is given, even at the given instant, t is also remains constant, only m, kinetic energy, is inversely proportional to m. If the two different charges are injected at the same time, then with the same initial velocity and everything, then this equation plays a very important role in understanding, and the twisting of the problem comes from here. Be careful, you'll solve 2-3 problems, you'll understand. This is what the kinetic energy of electron is. Force, direction, understood. Acceleration, force is opposite to E, acceleration is opposite to E, Vt is opposite to E, kinetic energy is E square t square upon 2m. And remember these things, this is the case of electron placed at rest. This is the electron placed at rest. Even the same thing, instead of electron, if you are going to keep the plus, that is a proton, the same thing, but the direction will change. That's it. If you sit and work out the same thing, same equation, you are going to get the same thing here. Practice properly and understand. Once you understood yourself and conceptually, if you are going to be able to analyze the situation and everything, there is no need to by heart the things. It is going to be very, very easy. This is a q square is nothing but, here I taken E, that is a t square by 2m. And next, the most important thing, ignoring G. Here, see, if I am going to keep an electron, then it has the mass, then it is, we are realize this everything in a space, then its weight of the mass of the electron is W is equal to m into G. We are going to ignore this m weight m into G because mass is very small and G is 9.8, and G is going to compare the acceleration, whatever the gained by the electron in electric field. In the numericals, we'll come to know that this G is a very, very, very ignorable compared to the acceleration of the charged particle in electric field. Therefore, we are going to ignore the G, and be careful, we are ignoring only in the problems if they are not mentioned. If they mention the weight and everything, at that time you have to consider the acceleration due to gravity. Unless and until they mentioned, we should ignore the acceleration due to gravity of a acting on a charge particle in electric field. Next, the next one is electron projected with initial velocity parallel to E. So the question is, now the electron placed at the rest with the zero initial velocity, this is over. Now electron projected with initial velocity parallel to E. The same thing. Second one, electron projected with initial velocity parallel to E. But parallel means, now the question arises, in which direction? Means this is a E, means parallel means this or this, means that's why we are going to discuss the two cases. If the electron is projected in the direction of E, and first case is electron is here, we are not going to keep the electron at the initial velocity 0. We are projecting now, we are injecting in electric field. Electric field in this case in the direction of E. In the direction of E means left to right. Now outside here electric field is going to be 0. Here this is a border, here the electric field is going to be starts. If I am going to inject an electron inside with initial velocity V0, which is greater than 0, means V0 is greater than 0 in the direction of electric field. Earlier V0 is going to be 0. Then what is the force? The force is same, F is equal to E. Why? Because we know that Coulombic force, electric force experienced by electric charge in electric field is going to be always independent of magnitude of initial velocity and its direction. Hence it is going to be force always experienced. This is going to be EE. The EQ means EE. So electric charge, and here also we come across this, always the direction of force is minus. You can write the minus here. This is a magnitude we are discussing, and here this is a V0 direction. Now the question is, what is the direction of force acting on it? Now the force acting on it, I will take another electron here. The force acting is always opposite to the Coulombic force experienced by an electron, always opposite to the electric intensity. This is the direction. This is the Coulombic force. This never going to change. Only thing is, this is going to be force is, this is going to be injected here, but the force is acting on this, means the force is acting in here and velocity I given in this direction. Now the force is acting, and we know that if this is a resisting force, because the object is moving in this direction and the force is acting in opposite, means this force making this velocity be nullified, or it is going to be reduce the velocity of the moving object. And here the acceleration is going to be there, and this is going to be accelerate in this direction, but velocity force is acting in this direction and acceleration is in this direction, but object is initially given the initial velocity, and we know that automatically the velocities go on reduces as it travels. Initially if it is going to be x, it is go on reduces to x minus delta x. It is like this, or v minus delta v, it go on reduces. How long it reduces? As is the acceleration is going to be reducing or retardation, unless it reaches the final velocity at a certain vf, this is become 0. This velocity of the electron comes to be 0 and it comes to rest. Once it comes to rest, again the rest event will start, and it start accelerating again in the direction of force. Because it has initial velocity, first it has to go on decrease its velocity, comes to rest, and again it start accelerating in opposite to electric field direction. Therefore retardation is the same thing, A is equal to E by M, and retard till it comes to rest. And velocity at any instant of time Vt, here we are taken earlier the V0 minus AT, here in previous case we taken 0, and here V0 plus AT, but is a retardation V0 minus AT. And this is equal to minus, if you substitute a here, this is going to be minus EET by m. This is the equation. Note, decreasing velocity till it comes to rest. This Vt is go on reduces because V naught is there, and EEM remains constant with the time. As the time increases, this factor go on reduces. This factor reduces means once it is reaches V naught, it is going to be 0, and this is going to be with the time, then this becomes positive. Once it is going to be 0, this equation becomes positive because at that time it start acting as a rest particle and it start accelerating. It just exhibit the previous case. And kinetic energy of electron. The kinetic energy, initially the kinetic energy of this one is, earlier when it kept at 0, initial kinetic energy is going to be 0. But here in this case, kinetic energy is going to be, initially is going to be maximum, and it is go on decreases because velocity, because of retarding force or resisting force and retardation, initial velocity is go on decreases. Hence kinetic energy is go on decreases with respect to time till it reaches the 0 velocity, and its kinetic energy is become 0 and slowly start gaining the velocity in opposite direction once it comes to rest. Therefore, kinetic energy of electron is going to be the same. It is remains same, but the with respect to time, it is go on reduces. What is that? Here to substitute whatever the velocity, if the time, it is going to be, we are going to calculate E square q by, there is 1 by 2 mvt square, this t. Velocity at any given instant of time, if you calculate, automatically Ke will come. And note, in the direction of electric field, electron loses its kinetic energy. Means if it is moving with the initial velocity in the direction of, injected in the direction of electric field, electron loses its kinetic energy because initially has its kinetic energy, it loses kinetic energy because a force of magnitude EQ or EE, QE means EE, is applicable on electron in opposite direction. Then the force is applicable on this, F is equal to EE. This is applicable, it is applicable on electron in opposite direction, opposite to initial velocity direction of electric field, opposite to direction of electric field, this. So its velocity decreases. Hence, this is moving in this direction, force is acting opposite, its velocity is gone decreases, and kinetic energy decreases till it comes to rest. This is what the dynamics, the theoretically, once the student understand, there is no need to by heart. Only thing is you have to analyze all the situation, and you can see the answer. Without seeing the answer, you can start telling the what it becomes. This is what the behavior of the charge. A student who understand this behavior properly, he can predict and he can start imagining the behavior of any charge particle. Tomorrow we are going to start understanding the electric, after this electric field, magnetic field, the charge, how it behaves and why it behaves, and especially what type of charge, positive and negative, and its mass, and comparison of the electron and proton and alpha particle and beta particle. All these things is a very basic thing student must understand. And the same thing, projected opposite the direction of, this is a second. Now this one is over. Electron projected with initial velocity, projected in opposite to, in the direction of electric field is over. We are derived A projected in the direction of E, and B projected opposite to direction of E. We will see that the projected direction of electric field. We will project it opposite to direction of electric field. It is as good as a charge E electron. If it is projected opposite to the electric field, and the force is also in the same direction, opposite, because electric field is this, electron experience the force opposite, therefore force is also in this direction. Hence it is going to be in as good as same, means is initially when it is at rest, when an electron is kept at rest, V naught is equal to be taken 0, but here in this case we are going to be taken as V naught is greater than 0. Then F, the simply F is equal to same, E acceleration remains same, Here instead of retardation, here is the pure acceleration. Initial velocities go on increases. Hence velocity at any given instant of time, it is as good as at initially at zero term, zero thing, but is added the initial velocity. This is the dynamics of velocity at any given instant of time. Vt is equal to velocity at any given instant, initial velocity plus at. A is the same, and substitute v naught et where. This is what the no need to remember. This is what you have learnt already. You have to substitute according to situation, and substitute velocity at this one. It is going to be greater than at keeping at the rest. E square q square t square by 2m. This is what the electron projected opposite direction of electric field with a certain initial velocity projected opposite direction of electric intensity. Yes, with this I request all the students to go through all the previous videos, understand the concept. This plays a very important role in whole PUC 2 to understand. You may understand the behavior of a charged particle, electric field, magnetic field. You may think that why the sir is explained so many times. You'll come to know when the questions and understanding the theory will come. It makes you so easy that everything flows like its own way. Anyway, thank you.